Good morning. Today we're looking at section 6.1, evaluating and graphing functions of several variables. This video will look at the first several exercises. For the first exercise example, we're looking at bank balances, and the idea is that the future amount is an initial deposit times 1 plus the annual rate divided by payments per year and years to raise the power of years times payments. When we think about this, what we're compounding quarterly initially, that the annual rate, however many years we have 4 times that many periods, and whatever the annual rate is, the quarterly rate will be 1/4 quarter of that. So we want to look at our problem for example 1. We're going to do an initial deposit. I'm going to make the initial deposit $1,000. I'm going to look at for 5 years, 4 payments per year. The annual rate is whatever the annual rate I'm going to start at. In our example, we start at an annual rate of 5%. So it's 0.05 or 5%. The final amount, well, let's break apart the formula as we build it. It's going to be the initial deposit. So it's going to equal the initial deposit, beat 1, times, we need to work out a period growth rate. Well, that's 1 plus the annual growth rate divided by the number of periods in a year. And we want to raise that to a power. And the power we want to raise it to is the number of years times the number of periods in a year. So instead of thinking of 5% for 4 years, we have we're dividing it, so 1.25% per quarter, and we've got 20 quarters. And so that gives us $1,282. And the difference is, instead of 5 years, for the example, we want 10 years. And we get the same answer the book has. One of the things that is being looked at here is this is really a function of 4 variables. I can change any of these 4 values, and it will change the final amount. And for any set of these first 4 values, there's a unique answer. So every set of 4 values, initial deposit, years, periods per year, and annual rate, results in one unique answer. If I want to make the annual rate 7%, I get more. If I change it to, I would like this to be compounded every week, that gives me slightly more. Notice that compounding every quarter gave me $2,001. Compounding every week gave me $2,012. Compounding 10 times a day gives me only $1 more than that. And so this is building a function. Notice we had our inputs, a formula that if I go to show formulas, I can see the formula, which is the same one that I had here, and that sets up our formula so we can do functions of several variables. Another example, which is more mathy, is I've got 2 demand prices and given quantities, and I'd like to find out the demand price and the revenue for something else. Well, really, when we do that, there is 4 variables. There's demand 1, demand 2, price 1, and price 2. So I'm going to fill those in. as 100, 200. The price to get 100 people to be interested in it is $20. To get 200 people interested in it, I have to drop my price to $18.75. If I want the demand slope, why, that's rise over run, and demand is the run and price is the rise. So I'm going to do price 2, so equals D2 minus B2 divided by D1, oops, I need to have parentheses there, D1 minus B1, and that's going to give me the demand slope. The demand intercept, well, I already have a point, and so I'm going to do, this is equal to, I take price 1, B2, and I'm going to subtract demand 1, B1 times the slope, C3. And that gives me a new price. My new demand, I'm going to just say, suppose I'd like to sell 500 units. I want to know what the price is. My new price is equal to times the new demand, or actually slope-intercept form, plus the intercept. And so what that says is, to get my price, my demand up to 500, I've got to drop my price to $15. And then there's my new revenue. And my new revenue is the new demand, how many I'm going to sell, times the new price, how much I'm going to get for that. And I see that I make $7,500. One of the things that's done in the book is I have gone and named these cells. Notice up here, the name for the cell comes up. And if instead of doing the formula that I did, D2 minus B2 divided by D1 minus B1, if I do clicking and try clicking on that, I'm going to say that was P2 minus P1 divided by parentheses D2 minus D1. Oops. Price 2 minus price 1. The demand slope, yes, the demand slope is negative. And similarly for here, price 1 is that cell times demand 1 plus the demand intercept. I mean, the demand, oh, new demand, okay, it's just price 1 times demand 1. Price 1, sorry, this should be price 1 minus demand 1, price 1, demand 1 times demand slope. One advantage of doing it this way is my formulas are easier to read when I go back if I've got full names. Let's look at example 3. Example 3, I want to have a table that gives the amount we need to deposit to have $100,000 in the bank in a variety of years and interest rates. And the formula is, I want my beginning balance to equal the final amount divided by 1 plus the rate times the number of, raised to the power of the number of years. So in all of these cells, I'm going to want B1 as my initial value. So $B, $1, divided by, parentheses, 1 plus, now my rate is right here is B2, but I'm going to drag that across. And when I drag it across, I want B to change to C and C to change to D. But when I drag it down, I want the 2 to remain the same. So I'm going to have B $2, close parentheses. I'm raising it to a power. I want to raise it to the power of the number of years. The number of years is in cell A3. And again, when I drag down, I want A3 to turn into A4 and A5 and A6. But when I drag across, I want A3 to remain A3, A3, A3. So I need a $ before the A. And that gives me an amount. Now I can quick fill. And so I see that if I have, let's do it a little slower. If I want $100,000 in 5 years and I'm getting 5% interest, I need to put in $78,000. If I get 6% interest, I only need to put in $74,000. If instead of 5 years, I'm saying I got 40 years to do it, this is retirement. To get $100,000 at retirement, I only need to put in $14,000 now with 5% interest and $9,000 with 6% interest. This is an exponential function and it grows that way. That's all for today. I will come back with other examples.